One of the biggest factors in determining the value of a home is square footage. The accompanying data represents the square foot and asking price for a random sample of homes, which is the explanatory variable. So square footage is the independent variable, and depending on what the square footage is, it will be priced accordingly. So price is the response variable. So the explanatory is square footage. Scatter plot. So let's open in StatCrunch. Stats, regression, simple linear. X is the first variable, Y is the second variable. And the next screen, so scatter plot should look like this. So let's see. Okay, where's the StatCrunch gone? Okay, so let's see. Okay, so as you have point here, then you have one above and one below it, and you have three at the same level. I think this is not working. So this looks like it. There was a point, then one above, one below, and then three at the same level. But let's double check with the data. So the square footage of 1100, it'd be 154. So 1100, this could be 154. And then with a 1096, you were 159, 1096, 159. This probably is it. So determine the linear correlation coefficient, and you know that screen also has a linear correlation. If you go back, so this is remember when we started correlation, I was saying that there are two ways. One is stats, summary stats, and correlation, but I never used that, and the reason is that that one only does correlation, whereas this one does everything. So therefore I'm just always using that, and we actually never need that other one. So the correlation coefficient here is this one, 0.9203, 9204. .92. Is there a linear relation between square footage and asking price? So in this case, they are not giving us the critical value. Remember, normally we have the critical value table against which we compare, and if this correlation is bigger than the critical value, then we say there is correlation, otherwise no. But generally, if you're above 0.9, it's pretty high, and in most cases, if even in real world, in most cases, if you get a correlation coefficient that high, you can safely say that yes, there is correlation. But in this course, definitely, if you get more than 0.9 and there are no critical tables given in the problem, then you can say that yes, there is correlation. And the least squares regression line was also seeable from here. So I give it in this funny way always. It's over here. So it's y is equal to 0.069x plus 82.11. 0.069x, so it was this one plus 82.11. Interpret the slope. Remember, slope is the change in y for each additional x. So here it will be the change in asking price for each additional square foot. So this slope is telling us that for each additional square foot, the asking price will change by 0.0694, but they say that it's in thousands of dollars. So 0.0694, it's actually, if you transfer the decimal place 3 places to the right, here, here, and here, it's 69.4. So what this is saying is that if you increase the square footage by 1, and then the price increases by $69.4. So for each square foot added, the asking price will increase by 69.4, yeah. Is it reasonable to interpret the y-intercept? So remember, y-intercept was the y value when x is 0. So in this case, it will be the asking price when square footage is 0, but zero square footage makes no sense. So it does not make sense. It's not reasonable. One home is 1092 square feet, is listed as 189,900. Is this home price above or below average? So what you will do is, for 1092 square feet, we have the model to tell us what the price needs to be. So if we put in 1092 for x, so let's see what we get. We get 0.0694 times 1092, and then plus 82.11. So I get about 158. So since this is in thousands, so it means the price of the home needs to be 158,000 on average. But this particular one is 189,900, so it's above average. So the model gives you the average price, and then you can see that whatever outside price is given is that above average or below. So this one is above the 158,000 that's given by the model, so it's above average. And then this one is very similar. Again, we have to interpret the slope and the y-intercept. And again, in this case, y-intercept will make no sense because that would mean the mileage given by a car whose weight is 0. And we cannot have a car of weight 0. So y-intercept is not reasonable even here. And then the next one is similar. And again, it's the hours that you sleep the night before the exam. So this one, what should be the predicted score for a history student who slept 15 hours? So you see 15 hours is not in this range. So this range is 3 to 8 maximum. So 15 hours, the model should not be able to predict it. So it's outside the scope of the model. So actually, that's telling us that this is the only choice. They have strange choices because, okay, the first one also says that 15 is outside the scope. So it could be either A or D. You have to determine the regression line. So and the same over here. Here, they say what be the predicted number for someone whose commute time is 95 minutes. So 95 does fall in this X range. So in this case, after you get the model, you will calculate it for X equals 95. And you should be able to handle all this. And the section is complete.